Hello students, this is Lalika from Learn Guru classes. So today we are going to solve some problems related to balancing a chemical equations, where we will practice some chemical equations, and as we practice I will tell you each and every step in detail. So if you want a detailed video of how to balance a chemical equation, what is balancing a chemical equation, what are the methods involved, a video is already uploaded on the YouTube channel. If you want, you can refer this video. So without further delay, let's begin our class. The first example is Xe plus F2 gives XeF6. Okay, so the first and foremost step, you have to write down the number of atoms in reactants and products for each element. So what are the elements available here? Xe and F. Okay, so let's write down the number of atoms in reactants. So Xe has only one atom and F2 has two atoms. F has two atoms. Now come to the product side. Xe has one atom and F has 6 atoms. So it's clearly visible that the number of atoms in the reactant and in the product are not same for F. So what has to be done? So it has to be balanced. Okay. Now if you see here, the number of atoms in reactant is 2 and in product it is 6. Means it is less than the number of atoms in the product. So if to make it equal, if we multiply this 2 with 3, that is the coefficient, okay, if we multiply 3, then the number of atoms will be same. So let's see, Xe plus 3 F2 gives XeF6. Now somebody may tell us that what is the use of multiplying F with 3 here, or what is the use of adding the coefficient here? Simply, if F is available over here, 2 into 3, can't we do? So that will also make F6, but it's the rule of balancing that equation that you are not allowed to multiply the subscripts, or you are not allowed to change the subscripts or the molecularity of or atomicity of the elements. Okay, only the thing you can do is that you can multiply the elements with the coefficients. Means you can multiply suppose this is F2, means you can multiply it before the element. Okay, so let's check here whether it's balanced or not. Again, we will repeat the same with the updated equation, that is this equation. So Xe has one atom here, and for fluorine it has 6 atoms. Now for products it has one atom and fluorine has 6 atoms. Okay, so here we see that the number of atoms in reactants is equal to the number of atoms in products, and thus the equation is completely balanced. So this is the Xe plus 3F2 gives XeF6. So that is the balanced chemical equation. Balanced chemical equation. The second sum is Ag plus H2S gives Ag2S plus H2. So first of all, we will write down the number of atoms available in the reactants and the products in this table. Okay, so what are the elements available? The elements available are Ag, okay, Ag, sulfur and hydrogen. Okay, so we'll write down the name of the elements or the symbol of the elements. Now see here, come to the reactant side. Okay, so Ag has one atom sulfur has 1 atom and hydrogen has 2 atoms. Okay. Here in the product side, Ag has 2 atoms, sulfur has 1 atom and hydrogen has 2 atoms. Okay. Now if we compare the atoms in both these two columns, we see that there is a mismatch in the number of atoms for Ag. Okay, so if you see here, now see carefully that reactant has 1 atom and product has 2 atoms. So what can be done? If we multiply the reactant side with 2 coefficient, okay, so I think the problem can be minimized. So let's see again how to do. We will write the updated equation. Okay, so this is written as Ag plus H2S gives Ag2S plus H2. So this is the equation that we find it before balancing. Okay, now if let's multiply Ag with 2 and again we will check the number of atoms in reactants and products. So Ag, sulfur and hydrogen. So we see that 2, okay, sulfur has 1 atom, hydrogen has 2 atoms. For the product side, silver or Ag has 2 atoms, sulfur has 1 atom and hydrogen has 2 atoms. So we see clearly that what? We see clearly that the number of atoms in reactants is equal to the number of atoms in products and the equation is completely balanced. Okay, so we see here that it is balanced by just multiplying the coefficients, okay, multiplying the element with the coefficients without changing the molecular formula, okay, or without adding anything to the subscripts. Okay, so let's move on to the next example. So the next example is MgOH2 plus HCl gives MgCl2 plus H2. Okay, so let's write down, as usual, write down the number of elements. Okay, what are the elements present here? So magnesium is present here, chlorine is present here, then hydrogen is there, oxygen is there. Okay, so now our turn is to find out the number of atoms in the reactant side. So magnesium has 1 atom, okay, chlorine has 1 atom, hydrogen has here 1 and here 2 atoms, so 2 plus 1 gives us 3 atoms and oxygen has 2 atoms. Okay, here come to the product side. Magnesium has 1 atom, chlorine has 2 atoms, hydrogen has 2 atoms and oxygen has 1 atom. So where are the mismatches? You can say it clearly that chlorine, there is a mismatch, hydrogen also there is a mismatch and oxygen also mismatch. So what can be done? Okay, so before that you have to remember one thing that I have discussed in the video where I have explained you balancing in complete detail, that whenever we encounter any type of metal, non-metal, hydrogen, oxygen in any equation, in any chemical equation, okay, and if we see the mismatches between metal, non-metal, hydrogen, oxygen, first and foremost priority should be given to metals, then comes non-metals, then comes hydrogen and oxygen. Okay, so metal, magnesium is a metal, right? Magnesium is a metal, but in magnesium it is already matched. Okay, atoms are in reactants and products is exactly the same, but chlorine is a non-metal, In chlorine, we see that there is a mismatch. And hydrogen and oxygen, obviously there is a mismatch. Now, what has to be done? Okay, what corrective measures have to be taken? So, if you see the number of atoms in reactant is 1 and number of atoms in products are 2. So, the problem can be solved only when we can multiply chlorine with 2, means we can multiply this HCl with 2. Now, let's write the equation once again. So, we have the equation as MgOH2 plus HCl gives MgCl2 plus H2O. Okay, so before here let us multiply this HCl with 2. Okay, now again let us tally the number of atoms in reactants and the products. So the elements available here are magnesium, chlorine, oxygen and hydrogen, right? So magnesium 1 atom, chlorine has 2 atoms now because 2 has been added here or 2 has been multiplied with HCl. So magnesium has 2 atoms now. Coming to oxygen, obviously 2 number of atoms are there, and hydrogen. Now the updated number of atoms in hydrogen here are, see, here you have 2 number of atoms, okay, for hydrogen, and here also you have 2 number of atoms for hydrogen. So the total is 4. Now come to the product side. Magnesium has 1 atom, chlorine has 2 atom, oxygen has 1 atom and hydrogen has 2 atoms. So here if you see, metal is completely balanced. The non-metal, that is chlorine, is also completely balanced. The difference lies in oxygen and hydrogen. Okay, so how this can be solved? Now you see over here that here in the reactant side, now hydrogen atoms are 4, right? Hydrogen atoms are 4, but in the product side it is 2. So it can be easily solved if we multiply hydrogen with 2, okay, or not hydrogen, H2O with 2. So let's write down the previous existing equation, that is MgOH2 plus 2HCl gives MgCl2 plus H2O. Now here, as in the previous case, it's 4 atoms in the reactant side and 2 atoms in the product side. So to make 4 atoms for hydrogen, we will simply multiply water or H2O with 2. Now let's check the updated number of atoms in the table. So elements available here are magnesium, chlorine, oxygen, hydrogen. Magnesium 1, hydrogen, chlorine 2, oxygen 2 and hydrogen 4. Come to the product side, magnesium 1, chlorine 2, oxygen obviously 2, as you have multiplied it with 2 H2O. So now oxygen has 2 atoms, 2, and hydrogen has 4 atoms. So see, here we are getting perfectly the number of atoms in reactants equal to the number of atoms in products. So we say that the equation is completely balanced. So thus the balanced chemical equation is MgOH2 plus 2HCl gives MgCl2 plus 2H. Let's come to the fourth equation. KNO3 plus H2CO3 gives K2CO3 plus HNO3. So let's write down the number of elements in the product and the number of elements. So you have potassium K, nitrogen, carbon, hydrogen and oxygen. So let's calculate the number of atoms in reactants. Potassium has 1 atom, nitrogen has 1 atom, carbon has 1 atom, hydrogen has 2 atoms and oxygen has 6 atoms. Okay, so let's come to the product side. Potassium has 2 atoms, nitrogen has 1 atom, carbon has 1 atom, hydrogen has 1 atom and oxygen has 6 atoms. So if we see or compare the number of atoms in reactants and product, there is a mismatch in potassium and hydrogen. So according to the priority, you should give priority to a metal, okay, because potassium is a metal and hydrogen is obviously a non-metal. So you should give priority to potassium first. Okay, so see here, potassium has number of atoms in products as 2 and in reactant as 1. So simple, if we multiply potassium KNO3 with 2, so number of atoms in reactants and products will be same for the potassium. So let's write down the equation once again. So the equation is KNO3 plus H2CO3 gives K2CO3 plus HNO3. So here we will simply multiply KNO3 with or potassium nitrate with 2. Okay, now again we will write down the elements for atoms of reactants and products using this updated equation. So we will write down potassium, nitrogen, carbon, oxygen, hydrogen. So potassium now 2, nitrogen 2, oxygen here 2 into 3, that is 6, plus O3 3, that is oxygen has 9 atoms, carbon has 1 atom and hydrogen has 2 atoms. Okay, so in the product side, potassium has 2 atoms, nitrogen has 1 atom, carbon has 1 atom, oxygen has 6 atoms and hydrogen has 1 atom. Okay, so by balancing the metal, we see that we are getting the nitrogen becomes unbalanced, oxygen becomes unbalanced. So if we go to the priority listing, so priority should be given to nitrogen first. Okay, so again see here, the number of atoms in reactants is 2 for nitrogen and for product is 1. So to make it equal to 2, what we do, we can simply multiply HNO3 with 2. So the updated equation will be KNO3 twice KNO3, it was twice KNO3 plus H2CO3 gives K2CO3 plus 2HNO3. Okay, 2HNO3. So again we will write down the number of elements. So potassium, nitrogen, carbon, oxygen, hydrogen. Potassium 2, nitrogen is 2, okay, carbon is 1, oxygen is 9 and hydrogen is 2, right, 2. So in the product side, potassium already I have written as 2, nitrogen is 2, carbon is 1, yes, carbon is 1, oxygen now you see 3, and 2 into 3 that is 6, and here 3 that is 9, and hydrogen is 2. So we see that simply by adding 2 to HNO3 we are getting number of atoms in reactants equal to the number of atoms in products for each and every element. So 2 KNO3 plus H2CO3 gives K2CO3 plus twice HNO3 is the balanced updated equation. The next equation is NH3 plus O2 gives NO plus H2O. So, first of all, write down the number of elements here or the name of the elements. So, nitrogen, hydrogen and oxygen. So, nitrogen has 1 atom in reactant, 1 atom in product. Hydrogen has 3 atoms in reactant and 2 atoms in product, and oxygen has 2 atoms in reactant and 2 atoms in product. Okay, so here if you see that hydrogen, there is a mismatch in hydrogen. Okay, so hydrogen you are getting number of atoms in reactant as 3 and number of atoms in product as 2. Now, if you see this type of equation, like if it was 2, a number of atoms in reactant as 2 and number of atoms in product as 4. So, this 4 is just a multiple of 2, right? 2 into 2 gives us 4. So, simply you can write as 2. But 3 is not a multiple of 2. 2 is not a multiple of 3. Now, how to tackle this? So, you can make both the number of atoms in reactants and products same by multiplying the reactant with number of atoms in reactant 3 and products. So, 3 into 2 that is 6. So, here if we can make the number of hydrogen atom in reactant as 6 and number of atoms in product as 6, then the number of hydrogen atoms will be balanced. Okay, number of hydrogen atoms will be balanced. So, now how to tackle this? So, see here, if it is already 3, right? In the reactant side, hydrogen atoms is 3. So, here if we multiply it with 2, and in the reactant product side, it is 2. So, if we multiply it with 3, then both of them will become 6 and hydrogen atom will be same for both the two sides. So, let's write down the existing equation once again. So, NH3 plus O2 gives NO plus H2O. Okay, so here to make the number of hydrogen atom 6, we will multiply it with 2, and here to make the hydrogen atom 6, we will multiply it with 3 in the product side. Now again we will write down the name of the elements. So hydrogen here in the products reactant side it is 2 and in the product side it is 1. Hydrogen has become 6 and in the product side it is 6 and oxygen 2 atoms are there and here 3 atoms are there. Okay? No, not 3. Oxygen plus O plus 3O, that is, it is 4. Okay, 4 atoms are there. Okay, so now what can be done? You see here nitrogen is becoming unbalanced and oxygen is becoming unbalanced. So in the previous case, the priority should be given to nitrogen first, that is non-metal, then oxygen. So it is clearly seen that number of atoms in product is 1 and for reactant it is 2. So product, if we multiply it with 2, then the number of nitrogen atoms will become equal for both the two sides. Now let's write down the equation once again, updated equation once again. So this will be 2NH3 plus O2 gives NO plus 3H2O. So here, to make the number of nitrogen atoms equal, we will multiply it with 2, right? So here it is, again we will write nitrogen, hydrogen, oxygen. Nitrogen is 2, hydrogen is 6 and oxygen is 2, and for here number of atoms in products, nitrogen is 2, hydrogen is 6 and oxygen is 2 plus 3, that is 5. Now here mismatch lies in oxygen. So here 2 is not a multiple of 5, 5 is not in the multiplication of the table of 2. So what can be done? We will multiply the number of atoms for both the two sides. That is, for reactant it is 2 and for product it is 5. So 2 into 5 gives us 10. That is, to make 10 means if for both the two sides we have to make the number of oxygen atom 10, 10. So how this can be achieved? If we multiply 2 with 5 in the reactant side and if we multiply 5 with 2 in the product side. Okay, so how this can be achieved? This can be achieved by, here if you see oxygen, it is 2, right? So simply we will multiply it with 5. Okay. Now in the product side, oxygen is 2 atoms of oxygen here and here 3 atoms of oxygen over here. So what we can do is that we can multiply to make it 10. Okay, we will just split it. That is, we will multiply here with 2. Okay, and here we will multiply it with 2. Okay, so the updated equation, let's write down the updated equation, then the thing will be clear to you. Okay, so this is 2NH3 plus O2 gives 2NO plus 3H2O. Okay, so to make it 10 for the in the reactant side, we will simply multiply it with 5. There is no problem in it. But here we will, since 2 has to be multiplied over here, so this will be 2 into 2, that is, it becomes 4NO, and for if we multiply this water with 2, so it becomes 6H2O. So the equation is 2NH3 4NO plus 6H2O. I think the whatever I have tried to explain to you, it's clear to you. Okay, so write down the elements: nitrogen, hydrogen, oxygen. Nitrogen is 2 in the reactant side and in the product side it is 4. Hydrogen is 6 in the reactant side and in the product side it is 12, and oxygen 10. Here 4NO, so oxygen is 4 and here oxygen is 6, so 4 plus 6 is 10. So see here, it is becoming 10 in the reactant and the product side. So it is becoming equal. But the problem lies with hydrogen, because hydrogen it is 6 and it is 12. Okay, so 6 and 12, it is very easy because 12 is just a multiple of 6. So in the reactant side, if we just multiply it with 2, then it will become 12, and number of atoms in reactant side will be equal to the number of atoms in the product side. So here we will multiply it with 2. So what will become? Let us write down the existing equation once again. So this is 2NH3 plus 5O2 gives 4NO plus 6H2O. So here we will multiply it with 2 once again. So it will become 4NH3. So nitrogen, hydrogen, oxygen, nitrogen here 4, hydrogen 12, 4 into 3 is 12, oxygen is 10, number of atoms in products, nitrogen is 4, hydrogen is 6 into 2 is 12, and oxygen is 4 plus 6, that is 10. So we see here that the equation is completely balanced. So 4NH3 plus 5O2 gives 4NO plus 6H2O is the completely balanced equation. The last sum is FeS plus O2 gives Fe2O3 plus SO2. Okay, so like all the sums, we will write down the elements first. Fe, S and oxygen available. So the number of atoms for Fe in the reactant side is 1, in the product side is 2. For sulfur it is 1 in the reactant, 1 in the product, and for oxygen 2 in the reactant and 3 plus 2, that is 5 in the product. Okay, so mismatch is there in the iron atom and oxygen atom. So according to the priority, it should be given to the metal first. So we will try to equalize the number of atoms for iron first. So it is clearly visible that number of atoms in product is 2 and for reactant it is 1. So if we clearly multiply FeS with 2, then the number of atoms for both the sides will be equal. So let's write down the equation first. So existing equation first, that is FeS plus O2 gives Fe2O3 plus SO2. So here we will be multiplying it with FeS with 2. So here iron atoms become equal. So let's write down the updated number of atoms here. So this is iron, sulfur, oxygen. Iron is 2 for reactants, sulfur is 2, oxygen is 2, iron is 2 for reactant, sulfur in the product, sulfur is 1 and oxygen is 5. Okay, so here mismatch is there in sulfur and oxygen. So according to priority, priority should be given to the non-metal. So sulfur, if you see, number of atoms in product is 1 and in reactant is 2. So here if we multiply sulfur it with 2, then the problem will be solved. So let's write down the equation once again. So this is 2 FeS plus O2 gives Fe2O3 plus SO2. So here to make the sulfur atoms equal, we will multiply SO2 with 2, that is in the product side. So elements becomes Fe, sulfur, oxygen. So iron 2 in the reactant, 2 in the product, sulfur 2 in the reactant, 2 in the product, and for oxygen 2 in the reactant, and this is 3, and 2 into 2 is 4, that is 7 in the product. Okay, so we see here that iron is also balanced, sulfur is also balanced, but oxygen is unbalanced. That is 2 in the reactant and 7 in the product. Okay, so what can be done? So if we see here, neither of them are multiple of one another. Okay, so only one way out here is that we will multiply the number of atoms in the reactant and the product side. Okay, so what we are getting here, 14 means 14 number of atoms if we place in the reactant side for oxygen atom, and 14 number of atoms if we place in the product side, then the number of oxygen atoms will be equal. Now how to tackle that? Here, since it is 2, to make it 14 we have to multiply it with 7 for oxygen in the reactant side, and in the product side, since it is 7, to make it 14 we have to multiply it with 2 in the product side. Okay, so let's write down the existing equation once again. So the equation is twice FeS plus O2 gives Fe2O3 plus what? 2SO2, right? So here 2 in the oxygen and 3 plus 4, that is 7 in the product side. So to make it 14, we will simply multiply the oxygen in the reactant side with 7. Now to make oxygen atom 14 in the product side, what we will do? We will multiply this with 2, that is twice Fe2O3, and this with 2, that is 4SO2. Okay, 4SO2. So let's write down 2 into 2 have written here. So we will write here as 4. Now again we will write down the updated number of atoms. Fe, sulfur, oxygen. So here iron is 2 in the reactant side, sulfur is 2 in the product side, and oxygen is 14 in the reactant side. Okay, so in the product side, iron is 4, okay, oxygen if you see 2 into 3, 2 into 3, that is 6, and plus 4 into 2, that is 8. So 6 plus 8, it becomes 14. So oxygen becomes 14 here, and sulfur is 4 over here. Okay, so if we see, there is a mismatch again in the iron atoms and in the sulfur atoms, but it is way more easier because 4 is multiple of 2, isn't it? So 4 is a multiple of 2 here. So in the reactant side, if we multiply it FeS with 2, then it will become 4 number of atoms for iron as well as for sulfur. So let's write down the updated equation once again. So it becomes as twice FeS plus 7O2 gives twice Fe2O3 plus 4SO2. So this is the existing equation. So to make it 4 for both iron and sulfur atoms, we will simply multiply it with 2. That is 2 into 2, that is 4. So here we will rub this 2 into 2 and we will write here 4. Now again we will write down the updated number of atoms. So Fe, S and oxygen. So here iron is 4, number of atoms in reactant is 4, for sulfur it is 4, and for oxygen it is 14. Now for atoms in products, iron it is 4, okay, for sulfur it is again 4, And for oxygen, if you see 2 into 3, that is 6, and 4 into 2, that is 8. So that is 40. Yes, it is completely balanced. All the elements are balanced. So we can write that 4FeS plus 7O2 gives twice Fe2O3 plus 4SO2 is the balanced chemical equation.